Hello, my name is Leo. Welcome to the third part of Digital Logic, where we're going to talk more about sequential logic and about the apply of digital logic in programming. There are some timing parameters which are crucial for understanding of sequential logic, such as setup and hold time, which are summed up to give aperture time, and propagation or clock to output delay. All of them are presented on this graph below. Setup time is the minimum amount of time for which data from input should be held steady before an increasing edge of clock signal in order to latch the data on input of flip-flop correctly. Hold time is the minimum amount of time for which data input should remain steady after an increasing edge of clock signal, so as to enable change of output signal after this time. And finally, propagation delay is the maximum amount of time after a decreasing edge of clock signal, which is a time up to the point of time when outputs are given. So it is time which flip-flop needs to change its output after the clock edge. Metastability. Metastability is generally a characteristic of any electronic device to persist in an unstable, metastable state. And in digital logic, it is inability of logic circuit to settle a stable logic level, either 0 or 1. It can be caused by different causes, such as these two. The first cause is when sum of setup time and clock to output delay is greater than time between two edges of clock signal. So between falling edge of one and between rising edge of the next clock signal. And the other very common cause is when we pair two devices with different clock domains, also can occur this phenomenon of metastability. It can have serious consequences such as system failure or program crash, then chip damages, unpredictable acting of electronic circuitry, and so on. There are ways how to solve or barely fix this metastability issue, such as, for example, metastable hardened flip-flops, which reduce setup and hold time, and also D-type flip-flop cascades are another solution for this problem. Here you can see a clock generator from a desktop PC. Shift registers are cascades of flip-flops where output of each flip-flop is connected to the input of the next flip-flop, and they are mostly used for bit shifting. Bit shifting is shifting a bit array, so a row of some bits in a row, array of some bits in a row, left or right. It is very useful when we want to divide some number by 2 or multiply that number by 2. So for example, by shifting one bit array by once left, we get that number multiplied by 2, and when we shift right for one position, we get the same number divided by 2 by integer division. And here we have example of one bit array, so it is a equal to 45. In binary expression it is this bit array. Now b is this a shifted for 2 positions right, so it is 2 times divided by 2 by integer division, and then c is b shifted left for 1 position, so it is 1 time multiplied by 2. Bitwise operations are operations on bit arrays, such as AND, OR, XOR, and complement, and all of them you can see on the example of these 2 bit arrays, A and B, which are both have length of 1 byte, so 8 bits. They are mostly like logic gates, AND, OR, XOR, and complement, so they work on the same principle. So for example, AND, we have a 0 digit in one bit array and 1 in the other bit array, then 0 and 1 in AND gate give 0 in output, so in this case is also in this way. Comparison or relation operators are used to check if some relation is true or false. So they return sum of two Boolean true, which is 1, or false, which is 0. And they're also used in some statements such as if statement, while, and for loop. So they are statements and loops very commonly used in programming. So they're very, very useful. Their relation operators are part of conditions in that statements and loops. And more about that if statement, while, and for loop you're going to see in one of the next presentations about them. And it is very important to differ double equal sign, which means comparison, from equal sign, which means variable initialization, and for this we have also an example here. Now you've learned about sequential logic and about apply of digital logic in programming. Thanks for watching and stay with us.